We have some conversions that can take us from Cartesian to polar coordinates. We have r squared equals x squared plus y squared. We have tangent of theta is y over x. So let's go ahead and use these for part A. We have x is -3, y is 0. So r squared equals -3 squared plus 0 squared. That's 9. So we can let r equal 3. And then we have tangent of theta is equal to y over x. So that's 0 over 3. So that's 0. And so, of course, tangent of theta is equal to 0 in lots of different places. So we just need to look at where we are. -3, 0 is at an angle of pi. And so that's the one that we use. Of course, we could flip and use theta equals 0 and r equals -3. That would be fine as well. But we'll just go ahead and use this. And then for B, we have r squared equals square root of 3 squared plus -1 squared. So that's 3 plus 1, that's 4. So we'll let r equal 2. And then we have tangent of theta equals y over x, so -1 over root 3. Okay, again, we have multiple places where that's true. If we look at our unit circle, well, tangent is negative in quadrants 2 and 4. Of course, this quadrant here is a positive x, negative y. So this is in quadrant 4. So if we choose an angle down here, then we'll be good. So -1 over root 3, that happens when theta is equal to, let's see, negative pi over 6. And so then our coordinate then is r theta to negative pi over 6. Okay, now we want these in two different ways. So let's go ahead and flip around. If we flip the r value to a negative, then that just adds pi or subtracts pi from the angle, and so we can put a 0 there. It's funny that polar coordinate is actually the same as the Cartesian coordinate. And then here we can put a negative in front of the r and then add pi to this, and that gives us a 5 pi over 6. And so those are two different ways for each of these coordinates to represent these in polar coordinates.